Welcome to 2.2 Absolute Value Functions. In this part 1, we will first explore what absolute value is, and then the graph of absolute value. I will be embedding Desmos into this video. If you prefer to graph on your graphing calculator, I will link a how-to video in today's lesson plan. All right, so first off, what is absolute value? Absolute value is, by definition, a number's distance from zero. Sometimes we also refer to this as the magnitude of a number. So like negative 100 and positive 100 would both have a magnitude or absolute value of 100. So let's take a look at what absolute value looks like written down. Here's an example down here on this number line. To draw absolute value, we draw like large bars around a number. So we'll do the absolute value of negative 3. So if we look at where negative 3 is on the number line, how far is it from 0? It is 1, 2, 3 units away from 0. So the absolute value of negative 3 is 3. Let's try the absolute value of 3. How far is 3 away from 0? It is also 1, 2, 3 units away from 0. So the absolute value of 3 is 3. How about the absolute value of 0? How far away is 0 from 0? We don't have to move at all, so it is 0 units away from itself. Basically, I know we've all learned absolute value at this point in our mathematical career, but I want us to understand that the reason it's always positive or 0, right? It's never negative, is because it is a distance from 0, and that's why negative 3 and positive 3 both have the same absolute value. In the example I gave before, negative 100 and positive 100 both have the same absolute value because they're the same distance away from 0. Next, let's graph absolute value and see what it looks like. So I made a quick XY chart here. So we'll first do it by hand, and then we'll take a look at Desmos, and then explore what it looks like as a piecewise function. So let's do this in yellow. So I'll plug in a couple values here. Just a couple numbers, just randomly. All right, so then we plugged in some x values, and here's our function. So if we input negative 4 into this function, the absolute value of negative 4 is 4. The absolute value of negative 3 is 3, and so on. And then graphing this, here's what it will look like. So we can see that we have basically a V shape. So we have a line going that way and a line with a positive slope going off to the right. So that is why we can say V for value, because an absolute value function is shaped like a V. But we can see here that this is actually a piecewise function, also by definition. Yes, it's shaped like a V, but we really have one line with a negative slope here until x is 0. And then when x is greater than 0, we have a line with a positive slope going the other direction. So here is the actual definition of what an absolute value function looks like. It is a piecewise function split from when x is less than 0, it's one line, and for when x is greater than 0 or equal to 0, it is another line. Let's see what that line is. The slope of this line, we go down 1, right 1, down 1, right 1. So the slope of this line is negative 1. And then the y-intercept is at 0. So this is the line y equals negative 1x plus 0, or, simplified, just negative x. We don't need to write the plus 0. And it is that line when x is less than 0, here. Then this side of it, this second piece of our piecewise graph, the absolute value graph, is a line that has a positive 1 slope, up 1, or up 1 over 1, up 1 over 1. It has a 1 slope, and it also has a y-intercept of 0. So we would write that line as the line y equals 1x plus 0, or just y equals x. And that occurs when x is greater than or equal to 0. Now, could we have put this or equal to up here as well because they do share that point? Sure. I just chose to put it here. So this is the technical definition of the absolute value function. It is technically a piecewise function of 2 lines. and they split right when x equals 0. So that is the definition of the parent function of the absolute value function. All right, let's graph that on Desmos. We had the function, I'll write it in a darker color here, we had the function f of x equals the absolute value of x, or we defined it as the piecewise function that had a negative slope when x was less than 0, and it had a positive slope of 1 when x was greater than or equal to 0. All right, so I'm just going to input this. It's much easier than inputting a piecewise function into our graph, into Desmos. So let's just graph the absolute value of x on Desmos, and what we're going to do is hit the absolute value key right here, the absolute value of a. So absolute value, and then we'll put x, and that's pretty simple. So that one wasn't too bad. So you don't even have to put y equals or f of x equals. Desmos automatically knows that it is a function for you there. So we graphed the absolute value of x on Desmos. And then another really cool thing that you can do on Desmos is if you hit this settings key right here, the settings button, and then you hit this like table here, you can actually input x values in and see what their output is. So we can easily plug values in, and there's already a decent amount of values in here, but if we wanted to plug another one in, down here I could plug in negative 100 or negative 114, whatever we want. So, and then it'll give us our output. So that is an extra thing you can do on Desmos, is the table function. All right, here is a you-try problem. Go ahead and practice this either on Desmos or your graphing calculator, and then go ahead and hit pause and play again to see how you did. All right, the graph of this function looks just like the absolute value function, except it's shifted over 2 units to the right, which is what that -2 did with the x. And then that bottom point here, that vertex point, was shifted up 3, which is what the +3 did. So it looks just like that regular v function, except it is the point, instead of being at the origin, is at 2, 3. And then these 3 values, which you could double check in the table if you'd like. When we plugged in -4, we got an output of 9. F of 2 was 3, and f of 4 is 5. So let's just do a quick check. Let's just make sure the coordinate point 4, 5 is on our graph, just to double check that that's right. So do we have, when we plugged in 4, did we get an output of 5? Yes, we did. Great. When we plugged in -4, did we get an output of 9? Yes, that's what those values mean. When we plug in an x, our output is our corresponding y coordinate. And in the end, we say v for value because an absolute value function makes the shape of a v. So remember, v for value.